Yeah. Is it? Can I stop him? Hello. Yeah. Hello. My name is Ritwik, and I'm here to continue yesterday's topic. J chemical bonding. These topics will be covered today. Basically, the remaining portion of the chapter. So, Planck's bond theory basically explain. Lewis theory just explains how a molecule is formed, like the octet rule. Just explains the stability. Here, but Lewis theory doesn't explain a lot of things. VBT covers some of these things. Formation, strength of bonds, and shapes of molecules. సో ఒక్కొక్క టాపిక్ కి ఒక్కొక్క ఎక్స్ప్లెనేషన్ ఇచ్చాను. ఫార్మేషన్ ఇప్పుడు ఒక టూ ఆటమ్స్ ఫార్ అవేలో ఉంటే ఎక్స్పీరియన్స్ నో అట్రాక్షన్ అండ్ నో రిపల్షన్. అలా దగ్గరికి తెస్తూ ఉంటే దే ఎక్స్పీరియన్స్ అట్రాక్షన్ లైక్ గ్రావిటేషన్ అట్రాక్షన్. అండ్ ఇంకా దగ్గరికి తెస్తూ ఉంటే దే ఆల్సో ఎక్స్పీరియన్స్ రిపల్షన్. అండ్ ఆ ఒక స్టేట్ లో ది అట్రాక్షన్స్ అండ్ ది రిపల్షన్స్ బ్యాలెన్స్ టు రివైజ్ స్టేబుల్ స్టేట్. ఫిగర్ లో పొటెన్షియల్ ఎనర్జీ డయాగ్రామ్ ఉంది. ఆ రెండు ఆటమ్స్ ని ఒక సిస్టమ్ కింద తీసుకుంటే ఆ సిస్టమ్ ఒక పొటెన్షియల్ ఎనర్జీ డయాగ్రామ్. అండ్ దట్స్ ది గ్రాఫ్ ఆఫ్ యూ ఈక్వల్ టు సమ్ k1 by r^12 minus k2 by r^6. దానికి ఒక మినిమా స్టేట్ ఉంది అండ్ ఆ మినిమా దగ్గర ది మాలిక్యూల్ ఇస్ స్టేబుల్ అండ్ ది మినిమా డిస్టెన్స్ ఆఫ్ సెపరేషన్ ఇస్ 1. సో దట్స్ ది బాండ్ ఫార్మేషన్ ఎక్స్ప్లెనేషన్. అండ్ ఇనీషియల్ గా మాలిక్యూల్స్ ఫార్ అవే ఉన్నప్పుడు ది ఎనర్జీ ఇస్ జీరో. మినిమం ఉన్న స్టేబుల్ స్టేట్ వచ్చినప్పుడు ది ఎనర్జీ ఇస్ మైనస్ మినిమం. సో basically you minimum amount of energy releases. That's the bond enthalpy. Strength, like the strength of the bond key explanation. How atoms interact with each other. Atomic orbitals. How we overlap. How what VBT says is they interact through atomic orbitals. Orbitals is quantum mechanical concept. సో ఇప్పుడు టూ ఐటమ్స్ ఉన్న అటామిక్ ఆర్బిటల్స్ ఇంటరాక్ట్ అయితే బేసిక్లీ ది ఓవర్లాప్ విత్ ఈచ్ అదర్. ఓవర్లాప్ అన్నది షోమింగ్ ఫిగర్ కొద్దిగా ఇంటర్సెక్ట్ అవుతుంది. దట్స్ ది ఫార్మేషన్ ఆఫ్ బాండ్. మోర్ ఎక్స్టెంట్ ఆఫ్ ఓవర్లాప్, మోర్ ది స్ట్రెంత్ ఆఫ్ బాండ్. డైరెక్షన్ ఆఫ్ ఓవర్లాప్ బట్టి బాండ్స్ కేటగరైజ్డ్ ఇంటూ టూ బాండ్స్, సిగ్మా అండ్ ఫై బాండ్. సిగ్మా అంటే హెడ్ ఆన్ ఓవర్లాప్, ఇంటర్ న్యూక్లియర్ యాక్సిస్ కి బాండ్ న్యూక్లియర్. లైక్ సి ఇన్ కేస్ ఆఫ్ ఎస్పీ, ఎస్ కి సెంటర్ లో న్యూక్లియస్ ఉంటుంది, ఎస్ ఆర్బిటల్ సెంటర్ లో, అండ్ పి ఆర్బిటల్ సెంటర్ లో న్యూక్లియస్ ఉంటుంది. అండ్ వెన్ యూ డ్రా ది ఇంటర్ న్యూక్లియర్ యాక్సిస్, ది intersect the overlap region is going through the axis is going through the overlap region. In three examples ఇచ్చాను how sigma overlap pi overlap or parallel overlap. ఇక్కడ bond is parallel to internuclear axis and basically that is it. Examples pp overlap is one example. తర్వాత d orbitals వెళ్తే we can have more kinds of pi overlap. So pi bond, that's a mistake. Sigma bond has more overlap extent than pi bond, so strength of sigma is greater than pi. In case of multiple bonds, sigma bond forms first and over that forms more pi bonds. So if you put two atoms మధ్యలో first sigma bond form only, that means head on overlap. That's SS overlap or SP overlap or PP overlap, any kind. అండ్ దాని మీద మల్టిపుల్ బాండ్స్ ఫామ్ అవ్వచ్చు, 5 బాండ్స్. ఇక్కడ ఒక ఎగ్జాంపుల్ చూపించాను, ఇథైన్ ఎగ్జాంపుల్. ఇథైన్ ఈస్ so ithine is this thing, C2H. And the molecular atomic orbital overlap అనేది figure లో ఉంది. You can see two parallel overlaps and lateral overlap is not visible in the figure. The blue thing is the lateral overlap. So C triple bond C అంటే ఒక head on overlap ఉంది, 2 pi bonds ఉన్నాయి. That means parallel overlap. Yeah. Types of overlap. Okay. Speaking of overlaps, P orbital, it's like plus and minus color. Say two atoms here and B, and they have P orbitals. So the overlap is of 3 kinds. Positive అంటే with plus overlaps with plus. Negative overlap plus interacts with minus. And zero overlap. Yeah. Negative overlap, zero overlap. Which negative overlap కి ఫర్ ఎగ్జాంపుల్ ఇచ్చాను, జీరో ఓవర్లాప్ ఫర్ ఎగ్జాంపుల్ ఇచ్చాను. Positive overlap లోనే we'll have a bond, either sigma or pi bond. Shape explanation. దీనికి నార్మల్ అటామిక్ వాట్ దే saw was normal atomic orbitals bonding కి వెళ్తే they can't attain a certain shape or stable shape rather. So what they figured out was, like, say, suppose second shell is the valence shell. So you'll have 2s, 2px, 2py, 2pz. These things turn into 4 sp3 orbitals. Okay, let's see this. Yeah, so let's say oxygen తీసుకుందాము. Oxygen is 2s2, 2p2, oxygen excited, 2s2, 2p4. So that's yeah. This thing is round, this thing is always like this, and this is inside. So if the oxygen చుట్టూ ఇవి పెడితే they can't attain a certain bond. So what they figured out was hybridization. So these atomic orbitals will turn into 4 sp3 hybridized orbitals. Hybridization ఉన్న ఒక ప్రాపర్టీ ఏంటంటే they have a certain shape. function. And SP3 is a little complicated. Yeah, they have a certain shape, and that basically gives a shape to the molecule. The shape of overlap is shape of bonds. So that's the shape. Hybridization types SP, SP2, SP3, SP3B, DSP2, etc. Hybridized orbitals only form single sigma bonds. Hybridized orbitals only form sigma bonds. So in an atom, the number of sigma bonds plus lone pairs is the number of orbitals that are involved in the hybridization. They give equal number of hybrid orbitals. For example, 2s, 2px, 2py, 2pz. నాలుగు అటామిక్ ఆర్బిటల్స్ ఇన్వాల్వ్ అయ్యి they give 4sp orbitals. Bunch of examples of hybridization. First one, your s orbital and pz orbital overlap to give liquids. Yeah, that's sp overlap. First thing is sp overlap, and the figure 4 points and one thing, that's sp2 overlap. Yeah, that's sp2 overlap. So in the first case, the shape is linear. The bonds are like opposite. The plus bonds with another plus P or plus S maybe. In first case, the shape is linear. Second shape, trigonal planar. Third shape, tetrahedral. You can see the tetrahedron, the sp3 one. And figure 4.14, that's also a tetrahedral shape. But you can see that రెండు bonds place లో lone pairs వచ్చాయి. So those are not. So that's like H, O, H, like reverse V shape. So that's called bench shape. This was in West area. And the fifth figure 4.15, I think C2H4 one. Last one లో you can see that ఒక పై బాండ్ ఓవర్లాప్ ఎలా ఉంటుందో చూపించారు. Pi bond, the electrons are out of plane in pi bond, and all the sigma electrons are in plane. The blue plane is the sigma plane, and the black thing is pi bond electrons. SP, SP2, SP3 కాకుండా మిగతా hybridizations, usually these occur in complexes. But yeah, yes. DSP2 square planar, so basically the shape is square planar. Examples, nickel tetracyanide. Trigonal bipyramidal, the shape is like it's like these three are in a plane, and there are axial bonds. This is trigonal bipyramidal. Square pyramidal. It's the same thing. Of a plane was square and figure. Like, yeah, 4 bonds in a plane. 2 bonds axial. Octahedral, my website. This is octahedral. Pyramidal. It's like usually square pyramidal case lo you will have a lone pair. So this is how it looks like. ఈ నాలుగు ప్లేన్ లో ఉంటాయి. One these out of them. In the lone pair ఉంటుంది. So the lower pyramid is basically pushed up. 4 B's అన్ని ఒక ప్లేన్ లో ఉంటాయి అండ్ ఒక A and this isol B. These are in separate planes. This is fun. So, molecular orbitals here itself is too big to discuss in just half an hour or 1 hour. So important postulates and important points lesson. Atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. Atomic orbitals are monocentric, whereas molecular orbitals are polycentric. Okay, atom ki atomic orbitals define చేస్తే molecule ki molecular orbitals define చేస్తాను. Similar energy on atomic orbitals, they combine to form molecular orbitals. So say like 1s and 1s combine to form 2 molecular orbitals, sigma 1s and sigma 1 star. I'll show you in this paper. 2p 2p combine to form like 2p lo you'll have 3, inko 2p lo you'll have 3. When to combine అయితే you'll have 6 molecular orbitals. And they have different energies. Atomic 2p orbitals lo 3 orbitals they are degenerate, otherwise called same energy. But molecular p orbitals like sigma, like 6 molecular p orbitals lo each of them have different energies. And I'll just show you the picture. They have different energies. Some of them have same energies, but basically they have different energies. The number of molecular orbitals formed is equal to number of combining atomic orbitals. Atomic orbitals combined, the molecular orbitals are formed. One is known as bonding, while the other is known as antibonding. Yeah. So 1s combined అయితే you'll have sigma 1s and sigma star 1s orbitals. 2 new orbitals. Sigma star 1s orbital is called antibonding molecular, and sigma 1s is called bonding molecular orbital. Sigma star 1s కి sigma 1s కంటే ఎనర్జీ ఎక్కువ. సో ఎనర్జీ ఎక్కువ అంటే అకార్డింగ్ టు హున్స్ రూల్ ఫస్ట్ ఎనర్జీ తక్కువ ఉన్న వాటిలో ఫిల్ చేయాలి. అకార్డింగ్ టు అక్బోస్ రూల్ ముందు ఎనర్జీ తక్కువ ఉన్న వాటిలో ఫిల్ చేయాలి. సో ముందు ఎలక్ట్రాన్స్ ఫిల్ చేస్తే యూ హ్యావ్ టు ఫిల్ ఇట్ ఇన్ సిగ్మా 1s. సో దట్స్ బేసిక్లీ లైక్ బాండింగ్. ఎందుకంటే ఇప్పుడు if you have 3 electrons, you have to go in sigma 1s and one has to go in sigma star 1s. And ఏమన్నా బాండింగ్ చేయాలి అంటే you have sigma 1s first. So కింద low energy is like bonding and high energy is like bonding molecule. Okay, just as the electron probability distribution around the nucleus in an atom given by atomic orbital, the electron probability distribution around a group of nuclei in a molecule is given by a molecular orbital. So that's like the definition of molecular orbital. Atomic orbital ante it's like the electron probability distribution around that the density distribution around the atom. Here this is around the molecule. The molecular orbitals, like atomic orbitals, are filled in accordance with the Boss principle, obeying Pauli's equation and the principle. So your quantum number rules is so sigma equal to psi a plus psi b, sigma star equals psi a minus psi b. That's right. Psi a and psi b are your atomic orbitals if a and b are your atoms. So those are the wave functions. Sigma is your wave function of the bonding molecular orbital. What is psi a plus psi b? Constructive interference. Psi a minus psi b, destructive interference. So constructive interference here, we have more stable and more electron density. Psi a minus psi b here will have less electron density. And this is the thing I showed you. I talked about it. One is some two orbitals combined, they'll give sigma and sigma star. Yeah, that's combining atomic orbitals must have same symmetry about the molecular axis, which is like positive overlap, negative overlap. This is one rule. Combining atomic orbitals must overlap to the maximum extent. So that's right. మనకి జనరల్ కానీ if you do quantum mechanical calculations, this is one condition. The overlap extent you can then for function and a function maximum out of constraints. Just a point. Molecular orbitals of diandroping molecule are designated as sigma, phi, delta. Delta is when d orbitals get involved. On Silversky, it's only up to any two, like the number of electrons in the molecule is 20 maximum. So that we won't be dealing with delta. This nomenclature is sigma. Yeah, the sigma molecular orbitals are symmetrical along the bond axis, while pi molecular orbitals are not symmetrical. Picture shown. The internuclear axis is taken to be in z direction. It can be seen that a linear combination of two pz orbitals of two atoms also produces two sigma molecular orbitals designated as sigma 2pz and sigma star 2pz. Pictures, right side pictures, you can see this. Anti-bonding key star orderly bonding key star. Energy of 2pz molecular orbital is higher than that of 2px and 2py molecular orbitals. That's right. Sorry. ఇక్కడ రాయలేదు ఎనర్జీ ఆఫ్ పై టు pz. సారీ, it's missing here. So that's energy of pi to pz is greater than sigma star. Pi star to pz is greater than sigma to px and sigma to py, right? Reason చూపిస్తాం తర్వాత. It's in the energy diagrams. Bond order. Okay. It's say if Nb is the number of electrons occupying the bonding orbitals in the molecular orbitals diagram. Yeah. If Nb is the number of electrons occupying bonding orbitals and Na is number of anti-bonding orbitals electrons, then the bond order is given by this formula, half Nb minus yeah. And the bond order should be greater than 0 for the molecule to be stable. If it is equal to 0 or less than 0, a molecule is unstable, it won't exist. So, molecular orbital theory also explains why some molecules exist and why some don't. Magnetic nature, paramagnetic, diamagnetic. Paramagnetic, you have unpaired electrons. Unpaired electrons, you have a certain thing called magnetic moment. Meaning also, you can just remember the formula. Root over n into n plus 2. N is number of unpaired electrons. Absence of unpaired electrons, diamagnetic, magnetic moment 0. Paramagnetic is like it's having this magnetic nature, getting attracted to magnets. I don't know. Diamagnetic is like inert to magnets. So in the magnetic poles, your paramagnetic compounds get attracted to the poles, whereas diamagnetic just don't care enough. O2 molecule is paramagnetic. This theory proves this. So VBT lo ఉన్న major drawback ఏంటంటే O2 is found as diamagnetic according to VBT theory, but experimentally O2 molecules is are disrupted by magnetic field. So it's essentially paramagnetic. So this MOT says that O2 is paramagnetic. These are called molecular orbital energy diagrams. Moids, basically. This thing has four moids, I guess. No, this also has. This is not the complete thing. ఇంకా కింద కూడా ఉంటాయి. ఇక్కడ కనిపించే 6 rows ఏంటంటే యువర్ సిగ్మా పి అండ్ సిగ్మా స్టార్ పి ఆర్బిటల్స్. 1s 2s కింద ఉండాలి, బట్ దే ఆర్ నాట్ ఇన్ దిస్ పిక్చర్. సో yeah, sigma 2p, sigma star 2p, pi 2p, pi star 2p, and 2s are molecular orbitals. There is a thing called sp mixing. Reason flowers are level, which question. 14 electrons వచ్చాక, like molecules up to 14 electrons, they'll have this pi star 2p energy greater than sigma 2p energy. కానీ 14 తర్వాత the order is changes. Wait, no, sorry. Yeah, your sigma 2p will have more energy than your pi 2p. కానీ after 14 confusion. Molecules which have electrons less than 14 electrons will have pi 2p energy greater than sigma 2p energy. ఎందుకంటే sigma bond forms first, then pi bond. That applies here. కానీ they observe that from molecules after 14 electrons, they వాటికి pi 2p energy is less than sigma 2p. So in this case, it's like pi bond is forming first. Reason this energies alaga, they seem to be that way experimentally. So your molecular orbital energy diagram changes. So what is this? Increasing energy. So this has less energy than this has less than this less energy. So that's one thing to remember. Due to sp mixing, the molecular orbital energy diagram changes for molecules having more than 14 electrons and less than or equal to. This thing is for less than or equal to. This thing is for more than. N2 has 14 electrons. So that's enough. Good spectrum. sp mixing is done in less than or equal to 14 electrons. sp mixing is not in less than 14. You can say 14 electrons tarvata you will have your natural order. 14 electrons daka you will have pi bond forming first in the two peoples. Hydrogen bonding, last topic. When hydrogen is bonded to strongly electronegative element X, the electron pair shared between the two atoms moves far away from the hydrogen atom. As a result, the hydrogen atom becomes highly electropositive with respect to the other atom. Nina చెప్పిన polarity explanation. Basically, where a electronegative atom పక్కన అయితే your hydrogen has del positive and your other element has del negative charge. Since there is a displacement of electrons toward X, the hydrogen acquires partial positive, X has partial negative. This results in a formation of polar molecule having electrostatic force of attraction, which can be represented as the minus thing you can see, that's essentially like bond. No, sorry. This is the bond, but copy paste is this is a bond, and these are like attractions. See, the bond and the attractions. This thing has partial positive, this thing has partial negative. So positive and negative attraction. The magnitude of which one? So why hydrogen bonding is special? Simply because polarity ఎక్కువ ఉంటుంది in this case. Attractions ఎక్కువ ఉంటాయి. And the dipole moment of the molecule seems to be actually affecting the very properties of molecules to a very big extent. Usually dipole moment వల్ల you can only like ఒక మాలిక్యూల్ డైపోల్ మౌంట్ ఉంది ఇంకో దానికి లేకపోతే యూ కెన్ ఓన్లీ సీ డిఫరెన్స్ ఇన్ మ్యాగ్నెటిక్ ప్రాపర్టీస్ బట్ హైడ్రోజన్ బాండింగ్ వల్ల యాజ్ ది ఎక్స్టెంట్ ఆఫ్ పోలారిటీ ఇస్ సో గ్రేట్ కొత్త అట్రాక్షన్స్ క్రియేట్ అవడం వల్ల యూ హ్యావ్ మెనీ అదర్ ప్రాపర్టీస్ డిఫర్ లైక్ ఫిజికల్ ప్రాపర్టీస్ లిక్విడ్ ఉండాల్సిన మాలిక్యూల్ సాల్ట్ ఉండొచ్చు అండ్ స్ట్రక్చర్స్ ఎఫెక్ట్ అవ్వచ్చు అజెండా. The magnitude of hydrogen bonding depends on the physical state of compound. Is maximum in these are like not points. Which is maximum in the solid state and minimum in the gaseous state. These in solid state, closer molecules, closer attractions, more attractions. Gaseous state, far molecules, so less attractions. Thus, the hydrogen bonds have strong influence on the structure and the properties of compounds. So, see, the thing is, hydrogen bonding వల్ల the solid is more packed, more strong. అండ్ సాలిడ్ స్టేట్ అటైన్ అవడం కూడా ఫాస్ట్ గా అటైన్ అవ్వచ్చు బికాస్ అడిషనల్ అట్రాక్షన్స్ ఆల్రెడీ సపోర్ట్ చేస్తున్నాయి యూ డోంట్ హ్యావ్ టు ఫ్రీజ్ ఇట్ ఇనఫ్. టైప్స్ ఆఫ్ హైడ్రోజన్ బాండ్ ఇదంతా ఐఎమ్ డిస్కసింగ్ ఫర్ ఇంటర్మాలిక్యులర్ కేస్. So types of hydrogen bonding, intermolecular, intramolecular, those are the respective examples. Intermolecular is like between molecules. Intramolecular is like within the molecule. OH, intermolecular, you see this OH. In all the structural effect also, you will have certain kind of ring here. Aromaticity level, but this is a ring and this grants to additional step. And ring stone, of course. Ikkada, you can see the zigzag structure of hydrogen chloride. This is because of hydrogen bonding. Boiling point, intermolecular greater than intramolecular. The reason intermolecular, you have interhydrogen bonding, so compact structure. Intramolecular, you have loose structure because ఒక మాలిక్యూల్ లోనే అట్రాక్షన్స్ ఉన్నాయి. ఇట్ డజంట్ కేర్ అబౌట్ అదర్ మాలిక్యూల్స్. ఇంకా ఉన్న అట్రాక్షన్స్ కంటే తగ్గిపోతాయి ఇంటర్మాలిక్యులర్. సో ఇంటర్ ఈస్ బెటర్ దెన్ ఇంటర్. Dipole moment varies accordingly with hydrogen bonding, so be very careful. Questions వస్తాయి, then you can understand. Like ఇప్పుడు కేసులో you have intramolecular hydrogen bonding, so the dipole moment is actually like this. You can see this. Yeah, so dipole moment direction varies, the magnitude also sometimes varies. మనం మామూలు స్ట్రక్చర్ గీసినప్పుడు we might not count it, but hydrogen bonding తో స్ట్రక్చర్ గీసినప్పుడు it comes into play. So that's the theory effective there. We're gonna discuss some questions. Topic 3, first question. During the change of O to 2, O2 minus C incoming electron goes to the orbital. So O2's molecular orbital energy diagram is sigma minus sigma star minus sigma 2s sigma star 2. And here comes your SP mixing. Sigma which is 5 to pH 5 to pH. The natural sigma bond forms first and 5. 5 star, 5 star, 6 sigma star. 2 pH, 2 pH, 2 pH. O2 has 16 electrons, so which is okay. This is your O2 molecule. Bonding you like, bond order calculate చేద్దాం అనుకుంటే you have your bonding electrons equal to 10 and anti-bonding electrons equal to 6. So bond order equal to half of bonding minus anti-bonding. So that's your O double bond group. సో ఇప్పుడు కొత్త ఎలక్ట్రాన్ ఎంటర్ అవ్వాలంటే ఎక్కడ ఎంటర్ అవుతుంది? అఫ్ కోర్స్ ఇక్కడ ఎంటర్ అవ్వదు బికాస్ ఇట్స్ లైక్ హైయర్ ఎనర్జీ. సో యువర్ ఆన్సర్ ఈస్ 5 star 2 px. So second, HF has highest boiling point among hydrogen halides because it has discussed earlier. Your electronegativity fluorine greater than oxygen greater than nitrogen. And hydrogen bonding is basically polarity attractions for the. So your hydrogen bonding strength is HF greater than H2O greater than H3N, ammonia, water, hydrogen fluoride. Hydrogen has highest boiling point among hydrogen halides because it has hydrogen thing. So ఏం చెప్తున్నారంటే your boiling point is higher for HF amongst all halides. Okay, this is this is the boiling point order. HF greater than HX greater than HPA greater than HCl. These is an inorganic chemistry, but HF is highest because of strong hydrogen bond. Amongst the following species, the diamagnetic molecule is. So Diamagnetic key, you have to basically have even electrons. తర్వాత జీరో అన్పేడ్ ఎలక్ట్రాన్స్. సో ఇప్పుడు ఆడ్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఉంటే వన్ ఆఫ్ దెమ్ వుడ్ బి ఆబ్వియస్లీ అన్పేడ్. సో అట్లా చూసుకుంటే let me just follow. So NO has odd number of electrons, so option is eliminated. And all of your others have even number of electrons. Unpaired electrons allows actually through those molecular orbital energy diagrams. D2 is 10 electrons, so without sp mixing, something like this, right? Sigma 1 is sigma star 1 is sigma 2s, sigma star 2x, pi 2px, pi 2py. 10 electrons according to Aufbau's and Hund's rule. So you have unpaired electrons in B2. So answer is valid. And if you check that way, and no wait, O2 key I already drew before, it has unpaired electrons paramagnetic. So your answer is 0. And another thing, what do you say? The point of the mentioned Shayla's slides below. Isoelectronic molecules have same magnetic nature. Like say CO into, for examples, NO plus. Yeah, these things have 14 electrons. So all of these are diamagnetic. ఒకటి diamagnetic ఉంది, మిగతా రెండు paramagnetic, అలా కాదు. All of these are diamagnetic. We know it is diamagnetic, so ఈ రెండు కూడా diamagnetic. Molecular orbital diagrams ఇస్తే you can have that. But yeah, another thing, molecular orbital diagrams చేసేటప్పుడు అటామిక్ ఆర్బిటల్స్ రెండు సేమ్ ఎనర్జీ లెవెల్లో ఉన్నట్టు చూపించాను. బట్ మనం హెటరో అటామిక్ మాలిక్యూల్స్ కి గీస్తున్నప్పుడు దే యాక్చువల్లీ డిఫర్. లైక్ సే దిస్ ఇస్ కార్బన్, దిస్ ఇస్ ఆక్సిజన్, దీనికి 1s ఆర్బిటాల్ ఇక్కడ ఉంది, దీనికి 1s ఆర్బిటాల్ ఇక్కడ ఉండొచ్చు. బట్ దీస్ బోత్ కంబైన్ టు గివ్ దిస్ సిగ్మా 1 సిగ్మా స్టార్. ఎందుకంటే ఎనర్జీ లెవెల్ చిన్న డిఫరెన్స్ ఉంటుంది, బట్ ఇట్స్ నాట్ లైక్ హ్యూజ్ డిఫరెన్స్. సో దే కంబైన్ టు గివ్ మాలిక్యులర్ ఆర్బిటల్స్. So homoatomic key will have same energy level, but heteroatomic key or atomic orbitals energy is also different. Among the following molecules, which one is diamagnetic and has shortest bond length? Diamagnetic in the Chipman and the Chichello, shortest bond length. Bond length is inversely proportional to bond order allergic follow in the Chipman. So based on that, your C2 minus 2 has bond order equal to 3. So please watch. E2 minus 2 has same number of electrons as M2. So also magnetic. So your answer is C2 minus 2. 2 pi½ sigma bonds are present. That's basically bond order 2.5. So accurate you have to draw the molecular orbital diagram, but you can also check for bond order 2.5. Odd number of electrons, and for the Rasi Tuesday, you have N2 plus has bond order 2.5. N2 plus 0.5. O2 plus will have 1.5. How based on those molecular orbital energy diagrams? O2 has 2 and N2 minus N2 has 3. Like N2 నుంచి ఒక ఎలక్ట్రాన్ డిడక్ట్ చేస్తున్నావు. N2 లో లాస్ట్ ఎలక్ట్రాన్ ఎక్కువ ఉంది. These 5 things. So this is getting removed. So your bonding electrons is reduced to bonding electrons minus 1. So your bond order is reduced by half. Like last electron bonding orbital CC will have a deduction of half bond order. But antibonding CC will have like increase of half bond order. Like F2 నుంచి F2 plus చేస్తే you will have bond order 1 to 1.5. According to molecular orbital theory, which of the following is true with respect to Li2 plus and Li2 minus? So the question answer here you need Li2 wide. Li2 is 6 electrons. Sigma 1 is sigma star minus sigma 2 is sigma star plus bond order equal to 1. Li2 molecule can theoretically form bond order since bond order equivalence. ఎందుకు ఎక్కడ చూడము అంటే it is like it is formed under highly hectic conditions, not hectic, bizarre conditions. Very low temperatures or very high temperatures flow, you can see Li2. Li2 would be mostly solid, so it comes under solid. Doesn't matter. Li2 is a molecule, it is stable. So Li2 plus T will have bond order 0.5, right? ఎందుకంటే you're taking out this electron. Li2 minus also bond order 0.5. ఎందుకంటే you have this electron but you're adding an anti-bonding. So opposite effect. Bond order reduces by. Both are unstable, wrong. Both are stable. Li2 plus is okay. Both are stable. Yeah. Option C. According to molecular orbital theory, which of the following will not be a viable molecule? Condition bond order less than 0 or equal to 0. And helium plus 2 as helium is 2 electrons, right? Helium 2 plus 2, 2 electrons. So sigma 1s2 stable. He2 plus also stable. H2 minus is the same thing, so stable. So last option is H2 minus 2. It has 4 electrons. So that's like sigma 1 is sigma star. Bond order 0. So the following species is not the same question. Assuming 2s mixing into 2s 2p mixing is not operative, the paramagnetic species among the following is. So మనకి ఇచ్చిన అన్ని ఆప్షన్స్ లోనూ యూ విల్ హ్యావ్ 2s 2p mixing. So 2s 2p mixing ఉంటే you will have this kind of thing. With 2s 2p, without 2s PP, we have this thing. These both get triggers. And unique electrons filled and start say you will have C2 as a paramagnetic molecule. PM stands for paramagnetic. Stability of species allowed to. That's based on bond order. Bond order proportional to stability. Higher bond order, higher stability, of course. More energy impacting. Which of the following pairs of molecules or ions, both the species are not likely to exist? Again, bond order checks is equal. Bond order equal to 0 or less than 0, which is probably. Let's move on, I guess. The topic 2, first question. The correct statements among 1 to 3 are valence bond theory cannot explain the color exhibited by transition metal complexes. Of course, valence bond theory it only explains formation, the strength of bonds, the formation of bonds, and the shape of molecules. And these are in the ordinary molecules. Complex molecules, you will have like CFT, crystal field theory. That's another chapter, coordination compounds. So first thing is correct. Color explained. Valence bond theory can predict quantitatively the magnetic properties of transition metal complexes. Yes. Cannot. Valence bond theory valence bond theory అసలు పారామాగ్నెటిక్ డయామాగ్నెటిక్ గురించి డిస్కస్ చేయలేదు. So second option wrong. Valence bond theory cannot distinguish ligands as Valence bond theory cannot distinguish ligands as weak and strong. It can actually. Okay, this question is actually out of context. ఇక్కడ valence bond theory, this is for coordination complexes. Coordination complexes also can be explained by valence bond theory. దానిలో చాలా థియరీ డిస్క్రిప్షన్ యాడ్ అయింది. అది నేను చెప్పలేదు. సో జస్ట్ టేక్ ఇట్ ఫర్ గ్రాంటెడ్. ఆప్షన్ 1 is wrong. కలర్ ఎక్స్ప్లెయిన్ చేయలేదు, బట్ మ్యాగ్నెటిక్ ప్రాపర్టీస్ ఎక్స్ప్లెయిన్ చేయొచ్చు. అండ్ లైగెండ్స్ వీక్ అండ్ స్ట్రాంగ్ కూడా ఎక్స్ప్లెయిన్ చేయొచ్చు. So 2 and 3 correct. Theory ఇంకా డిస్కస్ చేయలేదు. Please don't take me for that. The correct statement about ICL5 and ICL4 minus. Both are isoelectronic species, but I'm mentioning over. Both are isostructural would be wrong because obviously ICL5 5 bonds, ICL4 will have 4 bonds and 2 lone pairs. ICL5 is like 1 lone pair plus 5 bond pairs. Check cheste sp3b2 hybridization. Shape is square pyramidal. ICL. Nothing discussed in the and ICL4 minus sp3b2 square planar. 2 lone pairs, 4 bond pairs. Two lone pairs will be axial and 4 bond pairs will be in a plane. ట్రైగోనల్ పిరమిడల్ ఓకే ఇది నిన్న డిస్కస్ చేయలేదు. లెట్ మీ డూ ఆఫ్టర్ దిస్ క్వశ్చన్. ICL5 square pyramidal, ICL4 minus tetrahedral wrong. Second option right. Last option is also wrong. So that's the question. నిన్న ఒక డిస్కస్ చేయలేదు. A bunch of molecules PCl3 F2 PCl2 F3. The structure would be like F PCl2 F3 number. ఎందుకు క్లోరిన్స్ అన్న ఈక్విటోర్లో ఉన్నాయి, ఫ్లోరిన్స్ అన్న యాక్సియల్లో ఉన్నాయంటే క్లోరిన్ ఈజ్ మోర్ ఎలక్ట్రోనెగేటివ్. సో దీనికి దగ్గరగా ఉండాలి అంటే యాక్సియల్ గా ఉండాలి. సో మోర్ electronegative would be placed on axial, less electronegative would be placed on equatorial, like in the plane. And lone pair would be in the equatorial plane. Fluorine is more electronegative than fluorine, so axial effect. Explanations are pretty simple, but it's just equatorial is essentially closer to nucleus. So lone pairs అన్నవి న్యూక్లియస్ కి క్లోజ్ గా ఉండాలి కాబట్టి equatorial లో పెడతాము. And fluorines are less alternative, so there is no harm for phosphorus in keeping less alternatives elements near them. More alternative దగ్గర పెడితే it will distort and electrons will be more closer to fluorine. And distance ఉండాలి. So fluorine is placed in the axial and Cl would be placed on equatorial. Lone pair should also be placed on equatorial. So like ECl3 molecule has fissure. PCl3 has 2 lone pairs, 3 bond pairs. ఇవి మనం బయట నుంచి చూస్తే this is nothing but your fissure. DSP2 hybridization. DSP3 hybridization. So that's the ion that has sp3 hybridization for the central atom is sp3d2 means, first of all, sp3d2 అంటే it's like 1 plus 3 plus 2 6 and 6 ఉన్నాయంటే మనకి బాండ్ పేర్స్ ప్లస్ లోన్ పేర్స్ నంబర్ కూడా 6 ఉండాలి. ICl2 minus okay and isoelectronic species, so it won't work anyways. sp3d2 hybridization. Question this. Yeah, I have to get back on the question. The size of isoelectronic species Cl minus Ar Ca plus 2 is affected by nuclear charge, of course. Isoelectronic species and think nuclear charge would be the only thing. If nuclear charge would be, the molecule would be smaller. The nucleus will attract electrons closer. In which of the following process the bond order has increased and the paramagnetic character has changed to dynamic? So odd number of electrons to even number of electrons. That's the win. Or that's one case. Kani, right? What do you say? There can be other cases also. First, then your even is turning into odd. So that's like impossible. Diamagnetic cannot be in odd number. Second thing, same. C low, your O2 is turning to O2 minus 2. O2 is paramagnetic and two unpaired electrons in it. Minus 2 ante you will be filling those two unpaired electrons. Molecular orbital diagram is some person. So your CEC right answer. Hmm. Total number of electrons in NO to NO plus. NO is 15 electrons, NO plus 14 electrons. Wait, both C and D are right answers in this case. Mainsలో key changes ఉంటాయి సో వారి మా రెండు మూడు ఆప్షన్స్ కరెక్ట్ అయినా ఏ ఆప్షన్ కరెక్ట్ అయినా కూడా ఇట్స్ పర్ఫెక్ట్లీ ఫైన్. Total number of lone pairs of lone pairs in I3 finals. I3 minus one important. This is your I3 minus structure. So three, 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 so 9 lone pairs. I3 minus is linear. Let's go to example for breadfruit. Lone pairs అన్ని axial లో ఉన్నాయి, equatorial లో ఉన్నాయి, and your atoms are in axial. అందుకే the V-shaped supposedly V-shaped molecule is not V-shaped. ఒకవేళ two lone pairs and two bond pairs ఉంటే it would have been V-shaped. Three lone pairs and two bond pairs ఉన్నాయి కాబట్టి it is linear. The group having isoelectronic species. You can do that question. The correct statement for the molecule CSI3 is it is a covalent molecule. Yeah, CSI3 is a covalent halide. Sorry, my bad. CSI3 is an ionic halide. Because CS is like the biggest cation and I is like yes, and it's still in the inorganic. I and another thing is I3 minus is more stable combined than like CS I. Fusion mostly forms ionic compounds because of its big size. Like the covalent compounds form very simple, but there are some covalent compounds for fusion. It exists as CVS plus and I3 minus ions true. I3 minus is stable in our structure. Ninth question is species having terminal shape is. So first of all, terminal shape under three bonds in the example seems to have that. SO3 is trigonal planar because zero lone pairs from three bond pairs. So So I cannot plan that. I can see. So I cannot. BRF3, again, issue, as discussed earlier. Then loan pay, typical loan pay, offload axial to other floating axial. SiO3 minus 2 is also trigonal planar. The last thing we use OSF2, which is thermally. Sulfur is the central atom. It's like S, F, F, A. This is your pen. According to school, sorry, assuming that school, let me just get back to the third question. So there is a formula for hybridization. Hybridization for central atom species. This third question, ICL2 minus, this is like I minus CL. You'll have three numbers. It's like I3 minus. So when I add in small those CM minus. So this thing is a sp3d. Infantry three lone pairs and two bond pairs. BRF2 minus, same thing. ICL4 minus iron fluorine minus. So that's like two more lone pairs. Apply kada electron side. This is fair then. Square planar shape is D2sp3. Your IF6 minus is actually a so this is D2sp3. Oh, this question actually has no answer. Yeah. For me, this question doesn't have an answer. So be wary of it. ICL4 minus has square planar shape, which is D2sp3, not sp3d2. So I'm not really the best option because others are sp3d, first option, second option, same. This third option. The fourth option is IF6 is first sp3 d3 because six bond pairs and one bond pair. Structure is pentagonal bipyramidal in a panel. Best option, third option, but there is no answer. So we are done for the day. I'm gonna close this. Thank you. Yeah. Bye.